So yesterday you guys had a couple of problems to work on.
And they were all great.
They were all great. So you guys had 81 through 83, right? You guys got any? You guys got any questions on those ones?
They were pretty easy.
Not,
Out of 10, I give them a 6.
not too awful. All right. Oh wait, no. Sorry, 93 to 97, right? I think I said something. 91, 93 to 97. Yep. All right. You guys are all good with those then? All righty. So today we're going to keep looking at some functions, and then we're going to see if we can come up with a conjecture or a statement about all of these little functions that we come up with. So I have we are on to 1.2.3, and we're going to do 1, 2, 4 today as well, because they kind of come together. So we're going to talk about family of functions. So when we talk about family of functions, when we're talking about families, they all have something in common, kind of like you guys with your families, right? You either got genetics in common or something in common. So family of functions, these should all look somewhat alike in some form or another. So you're trying to find the commonality amongst all of these little functions. So I got 4 of them for you. You ready? So we have x plus 2y equals 10. We have y equals negative 1/2 x plus 3. We have negative 4y equals 2x plus 8. And last but not least, we have y equals negative 1/2 x. So we got to see if these things have anything in common. All right. You guys think of anything they have in common?
They all got some Y's.
They all got some y's. They all got some x's.
Not all of them have a solid number.
Not all of them have a solid number, but like technically, if we wanted to, could we write plus 0 there?
Yeah.
And that wouldn't change anything. So, right, we could if we wanted to.
They're all trying to find why.
They're all,
Y equals mx plus b.
Oh, we might be able to, try and solve them all for y. What do you notice about the exponents?
Yeah.
They're all, the exponents are the little guys up above, right? So like technically like right here, right here, they're all 1, right? So if we kind of just like look at this guy right here, right? Anybody know what he would graph to? Somebody kind of said the form.
Negative 1, 2, it's a line.
It's a line. Yep. So anytime like your x is like to that first power and like your y is to the first power or that first exponent, we know it's going to be a line. So I wonder if these are all going to be lines. What do you think? Right. So let's go through them. And I think like if it's in this form, we're happy with that, right? Because anybody know what that form's called?
Slope-intercept form.
Slope-intercept form, right? So that one's already in that form, and this last one's already in that form. So let's see if we can work on these two and see if we can get them into slope-intercept form. So let's start with this guy, right? So if I add x plus 2y equals 10. So my goal is to solve it for what letter? Solve it for y. So I want to get y all by itself. So what do we want to move first? How are we going to move the x? Yep, subtract it from both sides. And we're left with what? 2y equals, and I'm just going to keep it as negative x plus 10, right? To kind of keep it in that y equals mx plus b form. And then what do we want to do? Divided by 2, yep. And I'm going to divide each little piece by 2. You could write the whole thing over 2, but if, oh, where's my little guy? Like if we look at this one, we didn't write it all over 2, right? So it's kind of like they separated it, so I'm going to separate it. So those are going to cancel, so y equals, can I write this right there as like negative half x?
Yeah.
Is that the same thing? Yep. So negative 1/2 x plus what? Plus 5. So now we're in that cute little form. So I'm going to throw a little blue box around the ones that we're good with. We're good with that one, we're good with this one, and we're good with this one, right? We just finished that one. So you ready to do this guy? So what do we got? Negative 4y equals 2x plus 8. Move it up for you guys. Give me a second so it picks up that other page. There you go. What are we going to do with that one? What do we want to solve it for? Y. We want to get y all by itself. So what are we going to get rid of? Divide by what kind? Yeah, I might as well go for the negative 4. Right. So divide by negative 4. Divide by negative 4. So y equals, what's 2 over negative 4? Positive or negative? Negative, yep. So negative 1/2 x. What's 8 divided by negative 4? Negative 2? Negative 2, right? So I think we got that guy where we want it to go, right? So now we got them all to be y equals. Can we come up with anything else we might notice about these guys? What was that? I wrote them all down. Yep. What else? Yes. Yeah, yep, good job. Yep, they all got the negative 1/2 x, and I heard that over there too. So what does that tell you? What's that negative 1/2?
That they all have the same slope.
They all have the same
They're
slope.
never gonna cross the curve.
They are never going to cross, and when they never cross, they're called parallel lines, right? So we could kind of graph it real quick, make it nice and sloppy, right? I know. There's a difference between a sketch, what do they refer to it in CPM? A sketch and a,
So that's actually
Exact.
yeah, kind of like, right, like a sketch or just, yep, and then the other one, they want it to be more exact, right? So we'll start with the negative 1/2 plus 3. All right, so this one, how am I going to graph that? What's the 3 telling me?
That's where you start on the x-axis,
X or Y?
you got a Y.
right?
That's the Y intercept, right? So we're going to start, and then we're going to have a slope of negative 1/2, right? So we're going to start at 3, right? So there's our first point, and then down 1 over 2. Or if you wanted to, you could go up 1 and back 2. It's going to give you the same line. How many points do you need to make a line?
2,
How many do we have?
3.
Well, yeah, we got 3, right? We're going to, me and my perfectness never works. But close enough, right?
Yeah.
And then, do you want to do this one?
Yeah.
Yep. So where am I going to cross the y-axis? What's my y-intercept? 0, and then I got a 1/2, right? Negative 1/2. So I'm going to cross at 0, down 1 over 2, or however, or up 1, back 2. Uh-oh.
She said, it's not so straight.
All right. Sometimes you got to use your imagination in life. All right. Oh, let's do this one. He's close. So on this one, what are we going to do?
Start at -2.
Start at negative 2. Down 1 over 2. Yeah, and then we got one more, right? So we're gonna cross at 5. 1, 2, 3, 4, 5. Down 1 over 2. Oh, close enough, right? So was our conjecture right? All these lines are parallel? Did they all come out perfectly parallel? Yeah, they're perfectly parallel, right? What's different about all of these lines? What was,
the same slope?
they all have the same slope, but what's different? We had anything that's
They
different?
have a different.
Y-intercept.
X.
They had different y-intercept. Yep, good job. Look at you guys go.
So like I have a question.
Yes.
What's the purpose of knowing where the lines are? Just because that's the question. Like what would the question be for?
It would be like, they'd give you all of those equations. And then they would kind of, either like, what do they all have in common, or what family of function do they all belong to? Like that type, yeah. So, or even if it asked you to graph it, so, and like that's the one, like with the Algebra 2, I mean, it's building on your Algebra 1 and your geometry that you guys went through. Algebra 2 is kind of like your end thing, so they try to everything gets thrown together in this class.
So is next pre-calc?
Yes, yep. And pre-calc is just, it's the first semester is pre-calc and the second semester is trigonometry. So the first semester, it's like, almost think of it, Algebra 2 on caffeine. Yeah, you're hitting a lot of your algebra. Yep. And then then the second semester is your trig. So it's like just barely touching on your sine, cosine, and tangent, and then running with all the other trig identities. Yes.
Wait, so do you have to take pre-calc and trig, or is there other math classes?
There's other math classes.
Okay.
I think, yeah. Yep. I know that, I guess I should say, I believe that there are some students that they sort of require you to take it. I don't know. I think it has to do with your EDP.
Yeah.
I'm
Right,
definitely
and
taking
then-
personal finance.
So, yeah. All right.
Nothing against you, but
I want the easiest one.
Yeah.
I want a math class that doesn't make you regret. You know? Like the
I don't
past.
think that's such a, I don't think it's a thing that can happen.
Cause like, I just felt it's just like those people that just lie, uncontrollably.
All right.
Which I hate
Whoops.
those people, but like I get it.
So now if we look at 1.24, and guess what? Function, guess what the word's gonna be?
Families.
No. Investigation, right? You're gonna do another one of those little investigations. Practice, practice, practice. Hey, can't run a marathon if you've never tried running before.
We don't have
I bet I could.
Yeah.
There is no way.
I tried.
Bro, I remember.
I might not be very fast.
So if we gave you guys this function and we said f of x equals 5 over x squared plus 1, and then minus 1 like on the outside of it, not part of the fraction. So, hey, what do you think this graph might look like?
Well, you go up, down, well, I don't know.
Yeah. So let's say if we can figure out a little bit of maybe what we came across when we were looking at those rational functions, because we know something about like denominators, right? Do we know anything about little denominators?
Well, it's the run. Well, if you're doing y equals mx plus b, but that's not bad.
Yeah.
Oh.
Wait, what was the question? Sorry.
What do you know about denominators, like numbers and
Oh,
denominators?
whatever.
X is 2.
You could put in x's too. Oh, you want to make a table? You can make a table, right?
I think he seriously thinks that x is 2.
Plus 1 is 5.
Well, if you put in 2, what do you get as an output? You'd have 5 over
Oh, wait.
4 minus 1, or plus 1, minus 1.
now I choose 0.
So that'd be 0, right? So that's 1 point on our graph if we go to make our graph.
I want to do 3.
Yeah, 2, 0.
So when you're making a table, does it matter like which numbers you pick for the no?
Mm-mm. You got any other numbers you want to try?
3.
3?
Plus 3 is a cool number.
Because 3 is a cool number.
Yeah, you put it in there.
So now we got what, 5 over, we're just going to kind of do a little bit of 3 squared is 9, 9 plus 1 is 10, minus 1, right? So you technically have what, a half minus 1? What's a half minus 1?
Negative.
Yeah, negative half. Oops, I can't write. Negative half. So at 3, I'm at negative half. You want to try any other numbers? Negative what? 2?
Sure.
Sure.
Okay.
Let's try negative 2. So that would be 5 over, what's negative 2 squared? 4. 4 plus 1 is 5, right? Minus 1. That's going to give us 5 divided by 5 is,
0. You get nothing. Nothing.
oh, yeah, 5 divided by 5 is 1. 1 minus 1 is 0.
No, I meant 5 divided by 5 is 0.
No.
Yeah, you don't know.
So are we trying to see if it's like a line or
I think you're just trying to grab it.
Yeah. You guys want to try any other numbers? Hey, can we watch the language, please?
Yes, ma'am. Can we do 4?
4? So if I put in 4, 4 squared is 16 plus 1 is 17. 17 minus 1. Well, 5 over 7.
That does not look fun.
Well, you'd have to find a common denominator, so your common denominator would be 17. So it'd just be
5 minus
17.
So negative 12 over 17.
Yeah, negative 12 over. So whereabouts is that gonna be?
Yep, right there. How did that? Whoa.
Are you gonna get to 1? No, it's still gonna be smaller than 1, right?
Yeah, but wait, without understanding it, I like threw my pencil down and it made it laugh.
Nice, nice. Maybe I made the right line.
That's cool.
Yeah.
Okay.
Are we ever gonna get our y value or our output to equal 1?
no?
No. So what's that gonna, or, sorry, let me rephrase that. Negative 1, right? So if we can ever get to that negative 1, what do we think we might have? Starts with an A. An asymptote, yeah. Yeah.
Hey, I didn't mean that, I'm sorry.
All right. So I bet you we're gonna have an, well, that's really bad.
We're gonna have a toad.
All right, we're gonna have, yeah.
A toad.
A toe.
We're gonna have like an asymptote going through negative 1, right? So when I look at this right side, it looks like I'm coming down and I'm getting really close, but I'm not gonna touch it. But I gotta try and figure out what's going on. Because like somehow, right, we're at 0 in 2 spots. So we probably should try some numbers between 0 and 2, right, to kind of see what's going on. Because like what's going on, you know, in this whole area, we don't know what's going on. So you want to try 1?
That's not gonna work. I'm just kidding.
We can try 1.
Okay.
Yeah. So what happens when I put in 1?
Yeah, some fun.
So I have 5 over 1 squared is 1. 1 plus 1 is
So it's 5 over
2.
minus
1. Yep. So what are we gonna get?
I'm not sure what it is.
What's 5 halves?
2.5.
2.5. 1.5. Yeah.
It's so much easier to split into a decimal sometimes.
It is. Oh, yeah. If it's a nice clean decimal, right? So at 1, we were at 1.5. So right about there. Oh. What's another value we could try? Want to put in 0? So what happens when I put in 0? I'm just going to keep my graph.
5/1
Oops.
minus 1.
Yep, so I'm putting in 0. So yep. So that would be 5 minus 1, which is 4. So at 0, I'm going to be at 4. Want to try any other numbers?
Do we need to try any of these?
What's happening right here with our graph? Because it looks like we're going up, right? But somehow we have this guy over here. So how are we going to connect him to this graph? So I'd maybe try -1 and see what happens. So what happens when I put in -1? -1 squared is 1. 1 plus 1 is 2 minus 1. What are we going to get there?
-1.
Negative or positive?
Ooh.
Yeah, it's going to be positive.
I'm just gonna do
You're all right. Okay.
I believe it was funny.
So now we can kind of maybe see what's going on because it looks like this guy is coming up. Whoops, I need my little guy. Looks like he's kind of coming up this way, right? But what do we see here? It's coming this way, right? What do you think is going to happen as I keep going to the left? We're going to get closer and closer and closer to that asymptote, right? So it's coming like this. Whoops, I need a thicker pen. And it's coming like that. Right? Yes.
Is there any other way to do this without making tables?
Family of functions, I guess. I mean, the more you practice it, the more like you kind of understand like what's going on with each one of them, I guess, in a sense. Like I know that on my bottom, I know that I can get that asymptote to be where it's -1. You said then you start learning patterns when it comes to them. Kind of like, when it first came with like lines, like with slope, like you never realized that they were parallel until you kind of practiced it enough and then you knew that the same slope meant that they were parallel. So we're just starting with these. So yeah, yep. Yeah. So we have that asymptote, yes. I don't have one. So we have an asymptote. So we need to name our asymptote, right? Toby, yep.
No, it's Toby.
So when do we have our asymptote at? Is it an x equals or a y equals? It's a y equals. When our y equals what? -1. And then there's this other little special thing, a little newbie today. When it comes to our y-axis, this is our y-axis. Our graph is said to be symmetric about the y-axis because in the perfectly drawn world, if I folded my graph on this axis, would they match up perfectly? Yep. So ultimately, when it comes to things that are squared in some form or another, you're going to get a symmetry to them. So for us, our symmetry is over the y-axis. So when we flip our graph, it's exactly the same on the other side. So it's called symmetric. All right, that's all I got for you.
I don't understand why.
If you think about it.